Today I would like to present about Leg 1, transfer functions and system response. As you can see here, this is the questions that we get, which is about mechanical system for part A and electrical network for part B. Let we start with part A, mechanical system. For part A, mechanical system, as we can see in figure 1, they have two mass, which is M1 and M2. That means they have two loops. First, let we start at M1. At M1, the connection in M1 is K1, K2, FV1 and FV2 at loop X1. The formula will look like this. Is K2 and FV2. At M2, the connection will be K2, FV2, FV3 at loops X2. So first, the connections between M2 and M1 is K2 and FV2. So let's start with this will be our second equation. After we get these two equations, we will create a matrix because they have two equations here. So it will end up like this. After we get this matrix, we will use this value and put it on the MATLAB like this. Next, for part B, electrical network. As we can see in this circuit, there have two loops, which is at I1 and I2. Let's start with the first loop. At I1, the component there is R1, C1, R2, C2, and this will make the formula will be like this. And the connections between loop I1 and loop I2 is R2 and C2. This will be our first loop. For the second loop, I2 will be L, the inductor, the resistor R3, R2 and C2. But first, the connections between I1 and I2 and I1 is R2 and C2. So this will be our second loop. As usual, after we get these two equations for this circuit, we will make a matrix. After done, we will use this value and simulate it on MATLAB like this to get the final answer.
For figure 1, it shows the first loop of the mesh. The transient response is between the start to the settling time is at 11.9 seconds, which is the graph will start to enter the steady state response. The rise time is at 6.48 seconds. We can conclude that to arrive at amplitude 1, the time taken needed is around 20 seconds, which make it good because the time taken is short. The steady state response is at 1, which make it accurately arrive at point 1, and it make things work properly. For stability, the step response show that from rise time to settling time is take around 5.42 seconds, and it is fast and make it not too stable. Next, in figure 2, we can see that the transient response is between the start to the settling time is at 11.4 seconds, which is the graph will start to enter the steady state response. The rise time is at 6.33 seconds, which is faster than step response at figure 1. We can conclude that to arrive at amplitude 2, the time taken needed is also around 20 seconds, which same as step response at figure 1. Make it good because the time taken is short. The steady state response is at 2, which make it accurately arrive at point 2 and it make this thing work properly. For stability, the step response show that from rise time to settling time it take around 5.07 seconds, and it is faster than step response in figure 1 and make it also not too stable. Finally, at figure 3, we can see the difference between step response in figure 1 and figure 2. The difference that we can see is that the rise time and the settling time for point 2, orange in color, is more faster than point 1 in blue color line.
For part B, the values for electrical system have already been decided. All of the values are equals to 1. And since function have been used to declare the S and V as the shortcut to develop the variables. The syntax covers both matrix A and A2. Matrix A was determined by performing mesh analysis. Next, mesh analysis also have been used to get matrix A2. Hence, it will obtain the value of VL. The equation was I2 equals to determinant A2 divided by determinant A. So, VL is equal to I2S. Coding was used to obtain the plot transfer function and output response. The numerator was set to 1100 while the denominator set to 2541. To create a continuous time transfer function, the name of the figure, and to create transfer function objects representing continuous time or discrete time transfer function in polynomial form, the syntax sys VL was used. Figure 4 shows the transfer function for VL.